Refer to the scatter plots. The 4 points in the lower left corner are measurements from women, and the 4 points in the upper right corner are measurements from men. Examine the pattern of the 4 points in the lower left corner from women only and determine whether there appears to be a correlation between X and Y for women. So if the points in a scatter plot appear to lie in a straight line, then there is a strong correlation between the two variables. The points in the lower left corner don't appear to lie on a straight line. They appear to form a square instead. So there does not appear to be a linear correlation between X and Y for women. So we're going to say there does not appear to be a linear correlation because the points do not form a line. So let's do this again. Examine the pattern of the 4 points in the upper right corner from men only and determine whether there appears to be a correlation between X and Y for men. So looks the same. The points in the upper right corner don't appear to lie on a straight line. They appear to form a square instead. So there does not appear to be a linear correlation between X and Y for men. So we're going to say there does not appear to be a linear correlation because the points do not form a line. Find the linear correlation coefficient using only the 4 points in the lower left corner for women. So let's go ahead and use StatCrunch to find the correlation coefficient. So we're working with X and Y. These are our two variables. Let's go ahead and open the graph. So the points are, the first point, the X value is 3, the Y value is 2. So it's a 3, 2, and a 3, 3. The next point is 4, 2, and 4, 3. So we go on stat, regression, simple linear. The X variable is in the X column. The Y variable is in the Y column. Click compute, and you can see that the correlation coefficient is 0, and the regression line is a straight line. It has no slope. So correlation coefficient R is 0. So do the 4 points in the upper right corner have the same correlation coefficient? They should have the same correlation coefficient. Yes, because the 4 points in the upper right corner form the same pattern as the 4 points in the lower left corner. Now find the values of the linear correlation coefficient using all 8 points. So let's go ahead and do that. Let's add the next 4 points to StatCrunch. So the next point is 8, 9. So X value is 8, Y value is 9, and this one is 8, 10. So 8, 9, and 8, 10. The next point is a 9, and a 9, and 9, and a 10. 9, 9, 9, and 10. Follow the same steps. Stat, regression, simple linear. X is our variable, and then we have a Y variable. Compute. And right away, we can see that our correlation coefficient changed. And now the regression line has a slope and it's increasing. So R rounded to 3 decimal places is 0.971. Now, using significance level of 0.05, what does R suggest about the relationship between X and Y? So now we have to use the critical value table to make decisions. So here's the critical value table. So N, in our case, our N is 8 because we have 8 points. That's our sample size. Significance level is 0.05. So our critical value is 0.707. So you're going to reject the null if the absolute value of R is greater than critical value. So RR is 0.971, which is greater than the critical value 0.707. So that means you're going to reject the null and go with the alternate. So then we can support the alternate, which means there is sufficient evidence to support the claim that there's a linear correlation because the correlation coefficient is greater than critical value. So there is sufficient evidence to support the claim of a linear correlation because the correlation coefficient is greater than critical value. So based on this result, what can be concluded? Should the data from women and the data from men be considered together, or do they appear to represent two different and distinct populations, and that should be analyzed separately? There are two different populations that should be considered separately.